Mhm.
Okay, well, the question one is draw a UML class diagram below to illustrate your example. And for this UML diagram, we decided to create three classes. So the first class is the user class that will be our parent class, and we have two children class that will be the student class and the librarian class. So the user class is composed from with the name and ID and email, the attributes. And for the methods, the user class has like set name and get name, and it has like some getters and some setters. And at the end also it contains like a print user info that will be just printing all the attributes for that class. And if we look at the children class, we will have the faculty and also the phone number for the student class and the position for the librarian. And we will be doing the same thing, just printing the attributes. And if we see in the right side of the screen, we will be looking at the classes. So this is the user class, student class, librarian class. And we can just continue. So for this project, we named the project like test prep, that is shown in the side part of our screen. And the package will be called CSCI 325. That is right here. So if we continue, the third question is asking us to just put our names in the project and in the documentation. So we have this project is made by Scarlett, uh, Scarlett Park, and for Armando Diaz. So we can see our names on the top, and we can also see our names on the code in case you want to make sure who are the authors. And for the fourth section, the fourth question is, for the parent class, add an additional constructor that takes different parameters. For reference, see the constructor phone code where we created a student class. So for this case, we can just look at the user class, and we have right here the public username, and we have another one called public user. But the difference between the first one and the second one is that the first one is like the default constructor, where the name, ID, and email attributes are assigned with known. And for the user, for the second user method, we have three parameters that will be calling the attributes for the class: username, user ID, and user email. So we will be assigning these three arguments to uh, this method. And you can continue.
Okay. The fifth question is asking if you can use this overloading method with a regular method. Yes, of course we can do it. For instance, if you see this code here, there are two methods that have the same method name, but both have different parameters. The first one requires three parameters, three integers, and the second one is requiring one string method and one integer method. If you see the main class here, it's using different parameters, and then if you see the output, it's working properly. The first one is calling the first method, and the second one with two parameters is calling the second method. And what I just showed here is called overloading. Okay, 7. take one of the methods that you coded in your parent class and code a method in the child class with the same name and the same parameters. If you see the parent class, there is print user info method. And if you see the student class, which is derived from user class, it has the same name method, but it's going to override the user method. It's going to override print user info method in the base class. So what I just explained is overriding. Okay.
Yes, so for the ninth question, it's what is encapsulation? And do you see encapsulation in this exercise? If so, how? So encapsulation refers to the mechanism of hiding the variables of a class and getting access only through methods like getters and setters. So yes, we use encapsulation in our code since the variables are declared as private. I'm going just to move a little bit the code on the top, and we can see here the faculty and phone number are declared as private and can be only accessed by other methods like get faculty and set faculty and etc. You can continue.
You should do the first 4 parts here.
Oh yeah. So for the thing question, and what test cases should be run to test the code you have written, identify at least 8 test cases. So as we can see on the right side, we have the classes, and we have one class, our main class, called test prep Java class. And in this main class, I'm gonna just move a little bit. In the 20 line, we declare a scanner that will be helping us to read the input from our command line. So next, we are going to just call the user class. In this case, well, this one is taking the default parameters or our default constructor, and then we are going to test our class with these inputs. So we are going to put user as username Scarlett. I'm going just to move a little bit to the class. That way we can see the inputs names. So our parameter is username, user ID, and user email. So I'm going to go back, and this will be our username, user ID, and user email. And so our first test case is taken as inputs the ones that I already mentioned, and then we are going to test our print line, and to see if our class is working, we are going to get the use the arguments that we send to our class. So for this case, we will be calling the get name, the get ID, and the get email. So we should be expecting to see, when we are printing this, we should be expecting to see the same values that we gave to the class. And so I'm gonna run this, and I'm gonna just move a little bit. So as we can see, we are printing in the 44 line. We are printing our username, and this is the get name that is here, right here, and our get ID and our get email. And if we see our terminal or our console, we can see the values, and the values are write. So for the C test case, we are printing just the print user info. So the print user info will contain, I'm gonna move to the user class, and at the end we have print user info that has just the same attributes that are declared for our class. And well, that one will be just the line theory. So we are printing my user, and if we can see my user doesn't, like, we didn't put arguments into the class, so we should be expecting to see the default values. So the default values are none. And if we see the console, we are looking here that the non values. And so this means that our test case is correct. So if we go to the our fourth test case, we will be printing our, well, we will printing our student name. So if we go to our console, we can see that at the end it's asking us to write down a student name. So I'm going to write my name. Okay. Hmm. No. Okay, I need to. Okay, so I don't know why it wasn't working, but okay. So I'm going to write my name and click enter. So here we are just setting the name, Scarlett will continue with the next methods.
Okay. So enter student name is here, and after that, the system is going to require student ID and email, faculty phone number. So I will put any, oh, okay, let me go back. I just put enter. Okay, here, Scarlett, ID, Scarlett, and email, spark@gmail.com. And faculty, computer science, and phone number is going to be any phone number. And then, since there is my student print user info method, it's going to show what I just wrote as my information. It's showing Scarlett, and my email, computer science, phone number. It's showing the result correctly. And the next one, I just put system out print line library's position, and it's going to get position in librarian. If you see the librarian class here, no position is the default constructor. So since I didn't put any position for librarian, it's showing librarian's position is no position, and then it's requiring librarian's name. Okay, then I'll put Armando and ID Diaz and email diaz@gmail.com and position librarian. And then since there is my librarian print info, it's showing what I just wrote. Username, ID, email, position, and this main class is finished. So the next question, polymorphism. What is polymorphism? Polymorphism means determining which method to run depending on data types. There are two kinds of polymorphism. One is compile time polymorphism. A good example for compile time polymorphism is method name overloading. When there are methods that have the same method name, the compiler chooses which one to run depending on the method's argument. The other one is runtime polymorphism, in which the compiler chooses which method to run while the program is running. Let's say you make a base class and derived class. When you make an array list to save items of the base class and derived class, if both have a method that has the same method name with the same parameters, the compiler will choose which one to run while the program is running, depending on the actual object type to which the element refers. So question 12, pick one of the test cases identified in step 10. Create a driver class and code the test causing case using polymorphism. So what I just explained is polymorphism, and a good example here is line 30 and 51. Line 30, it's asking print user info and for my user object. And this same method for my user one object is being used. So it is going to, this one is going to print the default constructor result, unlike the result of constructor with parameters. It is compile time polymorphism. A good example for compile time polymorphism is method name overloading. So as we explained above here, we put all test cases in the main class here. And it's working perfectly, correctly, perfectly right.
Mhm.
Okay, this is all.
That's all. Thank you.
Thank you.